Let us see concept of control area. In this control area says interconnected operation of power system for economy and continuity of power supply. The power system are interconnected. For the interconnected operation is incremental efficiency for fuel cost. If two generating station connected by a tie line, the load increment on station B, the kinetic energy of the generator reduces to absorb the same. Next, the generation increases in the both station A and B, and the frequency will be less than a normal at the end of the governor response period. The load increment will be supplied partially by A and B. The tie line power flow will change as well as. This is control area of single line, that is two area with tie line power. The tie line power flow will change if the frequency controller is placed at B. Then it will shift the governor characteristics at B parallel itself. The frequency will be restored to its normal value F sub S, reducing the change in generation of A to 0. We have to calculate the follow of A and B for the analysis purpose. The analysis meant give a useful overall governing characteristics of the operating units in any area can be represented by line curve of frequency generation. Then the governor in both the areas starts acting simultaneously to change in their respective areas, as well as supplementary control devices act after the individual governor responses over the following time constant or defined to explain the control sequence. That time constant of T naught is the area operating schedule frequency, T base I equal to line interchange and load change takes. T1 is a governor action intermediate of both A and B. T2 is instant governor action Jesus. T3 is regulator action. T4 is regulator action Jesus. The single area system always having uncontrolled case and controlled cases of static compensation. First, we have to initiate the static analysis of uncontrolled case. In this uncontrolled case, both the line system have to exhibit their traveling wave from the beginning and ceasing period. So those kind of action or activities says uncontrolled case. Then let us see static analysis of controlled case. In this controlled case, the charge of frequency regulation is much larger than A. Then load changes in A will not appreciably affect the frequency of system. It can be flat frequency control is useful only when a small system is connected to a much larger system. This is dynamic response of single area system. It took two kind of graphical representation. X-axis takes time in seconds, y-axis takes frequency domain. So both x-axis and negative y-axis can give a more confidential of constant and neglect constant time constants. This is multi-area system. This multi-area system having more different kind of explanation compare than single line diagram, because this multi-area having more compact action and interconnected multi-area system. That means the multi-area system having AGC response and dynamic response. So both response are having to exhibit their controlling equivalency. So the multi-area system are different compared than single area system. Let us see the multi-area system component. Each component or each operating system principle having more number of area coverage. The most power system control their generator according their area responsible. Each control area must have to uploading their adaptation. That adaptation says regulation, control strategy and the equipment interconnected across the power system, and that power system says various area covering. So all those things of says multi-area system over here. The multi-area system having the important controlling method is automatic load frequency control. That automatic load frequency control include ALFC, that mean automatic load frequency control. That ALFC is to control the frequency deviation by maintaining the real power balance in the system. So always the system having real power, so the ALFC can have to maintain their real power in the system. So the main function of the ALFC is to maintain the steady frequency, control the tie line flows, distribute the load among the participating generating units. So those all are classifications are very much important under the control of ALFC. Next, performance of AGC under abnormal condition. The performance can say automatic governor system, control of step change the magnitude of the speed, then suddenly increases by small amount of differentiation of power deflection consider due to the operation of power system. Then the load frequency control possess inherently steady state error for a step input. So usually procedure of dynamic response of the control loop can be evaluated. So the initial response also can be seen for any overshoot. This purpose considering the relatively larger time constant of the power system. Next, in a single area system, there is no tie line. I told a previous video. This tie line schedule always maintained by AGC control. The function of the AGC only to bring the frequency to the nominal value. That's it. Always this value will be achieved using the supplementary loop, and that loop explanation had been told by our previous PPT videos, which uses the integral controller to change the reference power settings. So, is to change the speed set point. Frequency basis control or frequency bias control. Frequency basis control in the sense we are going to regulate the dynamic response of the power system. We must to effect of a disturbance in the system derived, because both loss of generation and loss of load can be simulated by some imposing positive and negative step input on the variable power load. So we must consider the dynamic response of the areas of power system using the controlling equipment of frequency based control or bias control. This is dynamic response of AGC with PI controller. This PI controller says two different mode of graphs says dynamic response of AGC. So the PI in the sense proportional integral. In this dynamic response, it takes a frequency and time, which mean the step controlled input of single area system. Another one is step controlled area of AGC. So both graphical representation is given here. This is PI controller application to over power system. PI controller is proportional integral control. That means the proportional integral control always says many of power system application, which mean the power system always maintain a real power and correct the reactive power as much of voltage and economic wise, both the controlling device done by this PI controller applications. This is a reference of this interconnected system. Thank you.